Okay, in section 5.3, we're going to go a little bit deeper in the analyzation of rational functions. Here are kind of some steps for you to do. You need to factor the numerator and the denominator. You need to reduce it to its lowest terms, and you locate any intercepts of the graph. You're actually graphing it, the x-intercepts, y-intercepts. Your x-intercepts are going to basically be where the numerator equals 0. The y-intercept is when you plug in 0 for everything. And then step 4, you locate your vertical asymptotes. And you eventually will go into locating either your horizontal or your oblique. And of course, the information about horizontal asymptotes that we have previously done is right below here. This is the information you had earlier, right there with the horizontal asymptotes. If the numerator degree is less than the degree of the denominator, it's 0. If the degree of the numerator equals the denominator, it's the ratio of the coefficients, the lead coefficients, and then the degree of the numerator greater than the denominator. There's no horizontal. And the slant asymptote only occurs if the difference in the powers from numerator to denominator is 1. The denominator is 1 less, or the numerator is 1 more. You can use a graphing utility, graphing calculator, and kind of help you sketch it if you're trying to sketch by hand. Okay, problem 5.3, number 1. The first thing they were really asking you about was the domain. Well, when you look, or really the only thing, I guess, to some extent here, maybe your domain, and then your asymptotes. Your domain, the only thing you have to leave out is -4. That's what makes the denominator 0. So you also have a vertical asymptote at x equals -4. Horizontal asymptote, the highest power on the top is 2, 1 on the bottom, so there is no horizontal. The oblique asymptote is what occurs when you divide the bottom into the top. And I hope you remember synthetic division. This is the actual synthetic division that I've used to find the oblique asymptote. We are actually dividing the problem that we had out. Go up here, see if I can get up here and let you see. That's the actual problem. Your divisor is the x plus 4. So you take the opposite sign, think of what makes it 0, -4. The coefficients of the numerator, 1, -15, and -16. You bring the first term down, the 1, and then you multiply it by the -4. Put it under the -15. Add -15 and -4, get -19. You multiply, you get -76, and you add, and you get -60. So that is the remainder. You do not worry about the remainder. It is irrelevant completely. And your oblique asymptote is y is equal to x minus 19. And I've sort of drawn the graph here so you can see it a little bit right there. If you want to see that graph, I put the asymptote in. That's the way the graph looks. It's approaching, of course, the numbers are really crazy here. It's approaching -4 at that oblique asymptote. But of your choices on your class exercises is answer A.